Welcome to the mathacademy.net channel. My name is Bo. Today we address the question, can preschool children learn mathematics? And welcome to our guest, Alan, who uses contingency research in his work.
Thank you, Bo.
Alan, what is contingency research?
Contingency research looks for alternatives to choices that are presented as nature in order to prevent hidden patternization.
Thank you, Alan. Do you have a short answer to today's question?
Well, Bo, mathematics was created as a natural science about many. To deal with many, first we count many, then we add many. In school we only count in tens and add on top. In preschool, learning and playing go together. So here we can also count in icons, that is, in numbers less than 10. And here we can add both on top and next to.
But why count in other numbers than 10? And why add next to?
Because counting in different numbers means shifting units, which is another word for proportionality or linearity. And adding next to is another word for integration. Furthermore, reversing addition is just another word for solving equations. And proportionality, integration, and solving equations are core subjects in mathematics.
Can you please give some details, Alan?
Certainly, Bo. First we rearrange sticks to form icons. Thus there are 5 sticks in the 5 icon, if written in a less sloppy way. With this first order counting, each number gets its own icon, until 10. Changing 5 sticks into a 5 icon transforms 5 ones into 1 5s that can be used when counting in 5s by bundling and stacking a total in bundles of 5s. So what we can call second order icon counting counts in icon bundles, whereas third order counting counts in tens, as does the school.
But why does the number 10 not have an icon?
Because we don't use the bundle number when counting. Counting in 5s, we say 1, 2, 3, 4, bundle, 1 bundle and 1, 1 bundle and 2, etc. So we never use the word 5 or the icon 5 when we count in 5s. Likewise when we count in tens.
Can you give an example of icon counting?
Let us take a total of 7 sticks and count them in 5s. We count by taking away 5 bundles, which leaves 2 sticks unbundled. The bundle we represent with a stick in a left bundle cup, and the 2 unbundled we place in a right single cup. Instead of 2 cups, we can use 2 brackets, one for the bundles and one for the unbundled. Finally, we can write down the counting result using cup writing as T is 1 bracket, 2 bracket, 5s. Or we can use decimal numbers as T is 1.2 5s, where the decimal point separates the bundles from the unbundled.
But is it wise to use decimal numbers instead of natural numbers in preschool?
It is no problem. As we have just seen, the natural way to write a total counted in bundles is as a decimal number with a unit. So if we recount a total of 4 8s and 10s, we should write the T as 3.2 tens. However, the school writes it as 32, thus leaving out the unit and misplacing the decimal point. How natural is that?
I guess we can also count in other icons than 5.
Yes, we can count the 7 1s and 3s as 2 bundles and 1 unbundled, writing the T as 2.1 3s. Or, in 2 bundles, as T is 3.1 2s. Strictly speaking, we should write that T is 1.1 2s, since here 2 bundles is the same as a bundle of 2 bundles.
But bundles of bundles, isn't that too abstract for preschool?
It probably is. And there is no harm in overloads that leave some bundles unbundled. Thus we can leave a total of 4.13s as it is, or we can recount it as 3.43s, or as 2.73s, since 1 3s can always be changed to 3 1s, and opposite.
So recounting totals in different units is a typical task in preschool mathematics.
Indeed it is. As an example, we can ask the question, how many 7s are 5 3s? Of course, we can lay out 3 sticks 5 times and then rebundle them in 7s. Then we get the answer that 5 3s is the same as 2.1 7s. However, we could also use a calculator to predict the result.
a calculator in preschool?
Yes. We count in sevens by taking away 7 many times, and the calculator has a horizontal stroke to symbolize dragging away 1 sevens, and an uphill stroke to symbolize wiping away many sevens. The question we asked the calculator is, from 5 threes, how many times can we wipe away sevens? So we enter 5 times 3 divided by 7, and the answer is 2 dot something. To find the leftovers, we asked the next question to the calculator, which is, from 5 threes, we drag away 2 sevens, and is left with what? So we enter 5 times 3 minus 2 times 7, and get the result, 1. Thus the calculator predicts that 5 threes can be recounted as 2.1 sevens.
Normally calculators and formulas go together. But formulas, isn't that too early for preschool?
Not necessarily so. A total of 8 is counted in 2 bundles by the action. From the total 8 take away 2's, 8 over 2, times. This action can be abbreviated to a rebundle or recount formula. 8 is 8 over 2, times 2. Or with letters, T is T over B, times B. And from a stack of 8 we can remove a bundle of 2 from the top, and place it next to the remaining stack. This action can be abbreviated to a restack formula. 8 is 8 minus 2, plus 2. Or with letters, T is T minus B, plus B. And as we have just seen, recounting a total in bundles means acting these 2 formulas. First we bundle the total in B's, then we take these bundles away to get the rest. And, if we replace the 2 actions with the 2 formulas, the calculator gives the same answer.
So once counted, totals can be added?
Yes. Counted totals can be added, both on top and next to. With on top addition, the units must be the same. So if we want to add the 2 totals, 2 threes and 3 fours, we recount the 2 threes and fours as 1.2 fours, giving a grand total of 4.2 fours. And shifting units is just another word for proportionality or linearity.
What do you mean with adding next to?
If we place 3s and 4s next to each other, they are added as 7s. To find the total, first we add the 2 areas, 2 times 3, and 3 times 4, then we count the total area in 7s. And adding areas, by combining multiplication and addition, is what integration is about.
Alan, you also talk about solving equations?
Yes, Bo. Solving equation is just another word for reverse addition. I will give you 3 examples. First, let us look at the question, what is it that together with 3 gives 9? If instead of the question mark we use an X, then we get an equation. Using the restack formula on 9, we restack 9 as 9 minus 3 plus 3. Thus X is 9 minus 3. So by removing what was added, we see that the solution to the equation, X plus 3 gives 9, is the number 9 minus 3.
And the second equation?
The second equation comes from asking, for example, how many 2's give a total of 8. Using the rebundle formula on 8, we rebundle 8 in 2's as 8 over 2 times 2. Thus X is 8 over 2. In both cases we see that moving a number to opposite side with opposite sign solves an equation.
And the third equation?
The third equation comes from reversing integration, by asking, for example, 1 4's and how many 2's give a total of 2 6's? To find the answer, first we take away the 1 4's from the 2 6's, and then we recount the remaining in 2's. So a calculator can predict reversed integration by reversing multiplication and addition to subtraction and division, which later is called differentiation.
Alan, it seems as if the order of operations is different in preschool and in school?
Indeed it is, Bo. The traditional order is addition, subtraction, multiplication, and then division, which normally is considered the most difficult. However, totals must be counted before they can be added. So in the natural order, division and multiplication come first, describing the taking away and stacking of bundles. Subtraction occurs if changing one stick in the bundle cup to many sticks in the single cup. with two different kinds. Addition is the difficult operation, and both on top and next to addition requires recounting to make the units the same, or to find the total area.
Alan, you have not mentioned fractions?
Well, Bo, using decimal fractions or ordinary fractions only depends on what you do with the unbundled. Recounting 2 3s and 4s gives one bundle, and 2 unbundled, that added next to gives the decimal fraction 1.2 4s, and that added on top, counted in 4s as 2 over 4 4s, give a total of 1 and 2 over 4 4s, here describing the unbundled with an ordinary fraction. So both decimal fractions and ordinary fractions occur in a natural way when recounting totals in icons.
What happens when these preschool children begin ordinary school?
Ordinary school mathematics only allows third-order counting in tens. If all numbers have the same unit, we never change unit, and we never add next to. This prevents children from learning about proportionality, integration, and solving equations in primary school. To realize these golden learning opportunities, progressive schools will begin primary school with icon counting and next to addition, and use dices or dominoes to practice recounting, predicted by a calculator, as for example 4 3s gives how many 5s. And also use colors or plastic letters as coded numbers, raising questions as for example if C is 3 and S is 5, then a total of 4 C's and 5 S's gives how many C's. Other proposals can be found in my book, Mathematics as a Natural Science, about many showing how primary and secondary mathematics become easy when grounded in its roots, the natural fact many.
Bo, Alan, you have talked very little about 2 and 3-digit numbers.
Well, Bo, let us write a 3-digit number as 456, as we say it, that is, as 4 bundles of bundles, plus 5 bundles, plus 6 unbundled ones. Then we see that any number consists of a combination of 1-digit numbers and bundles. Multi-digit numbers are abbreviations, used after school. Why should they be forced upon children from their first school year?
Thank you, Alan, for sharing with us your view on preschool mathematics. Next time on the MathAcademy.net channel we look at Year 1 and Year 2 mathematics.